Hi, this is Mr. Ward, and I'm going to talk to you briefly about how to 14.2 and 14.3 and investigating outliers. So, you've been given this data, and it says use technology to find the mean, standard deviation, and the 5-number summary. Okay. The mean and the standard deviation we've talked about a lot. Some of you have said, I don't remember what the 5-number summary is. That's the stuff you need to make a box plot. That's the stuff you need when you're finding the interquartile range. So the 5-number summary is the minimum and maximum, the median, the first quartile, which is the median of the lower half, and the third quartile, which is the median of the upper half. Okay, so what do we mean by use technology? Well, you have a couple of choices. You can use a Google Sheet or you can use GeoGebra. I'm going to use GeoGebra because while I think it's a little clunky to work with, it does really quickly spit out this data. So I'm going to go over here to GeoGebra where I've taken all of this data and I've already entered it. So I just put all the data into each of these cells. Now you see the numbers don't look like they're the same thing, but if I hit enter, I can see the whole number equals 1.0803, and that's the first number. Okay, and if I keep going down through here, 2.22 is 2.223. And let's find 2.223. Notice there's a 0 on the end. That's the same as 2.223. So I've got all the data in here. I need to use technology to find the mean, standard deviation, and 5-number summary. So I click on this thing that looks like a histogram. It should give me one variable analysis. Oops, it's not. Oh, you know what I need to do before I do that? I need to select the data. Notice it gave me a histogram of one piece of data. Okay. So I've selected the data. Now I hit it. It gives me one variable analysis. I click one variable analysis. And I go over here and I hit what this is, the summation function. Okay. So N is the total number of data, the 37 pieces of data. Here's our mean, which is one of the things we need. This is the standard deviation for a population. This is the standard deviation for a sample, the difference between these two numbers. So this is the Greek lowercase sigma. This is the English alphabet letter S, lowercase s. So sigma, lowercase sigma, is when you divide by n when you're working your way to the standard deviation. The letter S stands for the situation where you're dealing with a sample, and you divide by n minus 1. You divide by 1 less than the total count of pieces in the data. I'm going to skip over these two. This is just the sum of all the observations, and this is the sum of squared observations. This is the minimum. That's the lowest data point, and there's the maximum, and you need those. And then the median right here. And in order to get the quartile 1 and the quartile 3, you needed the median because you got to find the median between the minimum and the median. And that's the lower median. And then quartile 3 is the upper median. So that's these right here. These 5 are your 5-number summary. And there's your mean, and there's your standard deviation. And if it were a standard deviation of a sample, it's that. So let's consider whether we want the standard deviation of a sample or the standard deviation of a population. All right, this is a data set of the, well, we've selected certain countries here. It's not all countries. So perhaps we want a sample. I'll let you consider that. I think there is a case to be made for getting a standard deviation of just this because we're just treating it as a population. If it was a sample, if we're thinking about a sample, we're trying to get a representative sample. Maybe we weren't trying to get a representative sample. Maybe we were just trying to get the data for the top healthcare spenders around the world or the largest economies in the world. I don't know what it was that they grabbed. So there's some discussion that one would need to have. The maximum value of this data represents the spending for the United States. Should the per capita health spending of the United States be considered an outlier? Well, if you recall, we need to find out if that value is more than 1.5 interquartile range values, greater or less, greater than the quartile 3, or in the case of a lower number, lower than the quartile 1. So I'm going to go ahead and work that out. So we know the quartile 3 and we know the quartile 1. So I'm going to just do a calculation, equals 4.7963 minus 2.1863. And that's going to get me the interquartile range. At least it should. It looks like it did not. So I'm going to have to do this using a different tool. So I'm going to use, let me go here. It's not letting me grab that number. So I'm just going to have to open up a Google Sheet Drive. I'm going to pause so you don't have to watch me go through all. Okay, so I've grabbed the maximum and the minimum, and I put it in a Google Sheet because I find it a little easier to maneuver this sort of thing. So I'm going to first find the interquartile range, which actually, I'm sorry, that is not the max and the min. That is Q3 and Q1. Okay, so I've grabbed the quartile 3 and the quartile 1. Okay, equals quartile 3 minus quartile 1. And so what I did here to make this formula, I said equals, and I moved the arrows to the first cell I wanted, and so it selected B1, and I hit minus, and then I moved the cursor to the second cell that I wanted, okay, and that's B2, and I hit enter, and that gets me the interquartile range. I don't want to autofill because I'm just referring to these two cells. Now I want to figure out what's 1.5 times the interquartile range. So I'm going to say equals 1.5, and then Shift 8 gets you an asterisk, which works as multiplication in here. And then I'm going to use the arrow key to move to the cell I want to multiply by. And I hit enter, and now that's 1.5 times. Now I should go ahead and grab them, and this actually should not say max. That should say Q3. Like I like to say, brains are funny places. And mine was definitely 1 because it is, of course, 6:53 in the morning. So we're going to say equals. We're going to go to quartile 3. We're going to multiply that times our, we're not going to do that. Let me back up. Say equals, it's quartile 3 plus 1.5 times the IQR, which I've already calculated here. There it is. And if I'm at beyond 8.708, and this is, of course, $8,707 per person, then I'm suspicious as an outlier. I'll go ahead and do the same thing here, equals the quartile 1 minus the 1.5 times the interquartile range. And, well, that would be negative spending. So taking money away from people or something like that. I'm not exactly sure what negative spending on healthcare would look like, but we can think about that. So there you have the sort of range of stuff that would not be automatically suspicious as an outlier. Well, if you recall, the United States was here at 9.823. So we're definitely beyond the 1.5. So we should be thinking about whether or not that is an outlier. Okay, so although outliers should not be removed without considering their cause, it's important to see how influential outliers can be for various statistics. So if we remove the data from the data of the United States from the data set. So we're going to use the technology to find the new mean, standard deviation, and 5-number summary. And then how do the mean and all of that stuff compared to the original summary statistics. So let's go back and take a look at the original summary statistics. We've got them all here. I'm going to now select the data that I want. And it's very easy to just set up a new GeoGebra. And I'll put that data in. And then I'm going to go through here, and instead I can delete that last one, or I can just start selecting without including it. So I'm just not going to include it. I hit the graph to get one variable analysis. I go over here to the summation function, and we look at the new mean is 3.619. The old mean was 3.7886. So the old mean was a little bit higher. Now we look at the new standard deviation of 1.46. The old one was 1.76. You can also compare the standard deviation for sample if you like. The median for the old one is 4.0334. The new median is now 3.8115. We have a new maximum, same minimum, probably a new quartile 1. The median stayed let's see, the new quartile 1, let's see, so that's the new one, 2.1863, it's still 2.1863. And then we look at quartile 3. Quartile 3, the new quartile 3 is lower, 4.7305, but not much, and 4.7969963. Okay, so those are changes that you get. So you want to compare that. Now we get on to, I'm going to go ahead and stop this because it's getting kind of long.